Shamalam, shamalam, this is Dr. Dobo Jam. We brought a little goodies for you to taste, so open up your mind, there'll be no waste. Shamalam, shamalam, this is Dr. Dobo Jam. No way to escape, we got a hold on you. You're in this ritual, black and blue, yeah. Suck it to me, baby. This is Dr. Dobo Jam. We brought a little goodies for you to taste, so open up your mind, there'll be no waste. Shamalam, shamalam, this is Dr. Dobo Jam. No way to escape, we got a hold on you. You're in this ritual, black and blue. Talk it to me, baby. Got to play, yeah. You gotta sing it all the night, all the night, all the night. That's what I say, that's alright. Yes, sirree, yes, sirree, yes, sirree. I really gotta love it, baby. Got to play it for me now. Got to, yeah, 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 yeah. Got to play, yeah, yeah, yeah. Now we want to hear a little bit of organ touch, just a little bit of organ, baby, yeah, 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 yeah. You got to, you got to, you got to, you got to, got to, got to, you got to, you got to.
Hello and welcome to Farming Academy. Today we are gonna speak about proteins in the air. And the first thing we are gonna talk a little bit about is how to make a free learner's account at Farming Academy. And it's gonna be me who's presenting that, and I'm Jeanette Jensen. And after that, Dr. Carsten Petersen will talk about proteins, and then Pia Schmidt-Knudsen will talk about different sources of protein, and hopefully Karina Mikkelsen will join us She's stuck in traffic and she's on the way, so we hope to see her soon. But first, when you want to make a free learner's account on Farming Academy, you go in to FarmingAcademy.eu, then you can click on Classroom. That will bring you to the classroom. And when you come in here, you can click one of two places. You can click Sign Up for free, or you can click Sign Up. Then you'll get to a little quiz where you tell your name, your email address, you choose a password, and then you can choose what kind of special interest you have. And if you want to have some special offers, especially if you are a European citizen or maybe you are from Africa, you can click here, and then you have to accept the terms and conditions, and then you can start your learning journey. That's what it takes to become a learner at Farming Academy, and it's for free to sign up and get your own account. So now I will stop sharing my screen here. Just a second. Then we'll ask Dr. Carsten Petersen to come in and take over the lecture.
Yeah, thank you very much. Will you put presentation on?
Yes. Yeah, I'll do that. Just a second. Here you have the lecture.
Brilliant.
And you'll
Thank you.
just tell me when you want me to change slides.
Yeah, thank you very much. This is just a basic introduction to what protein amino acids are. So protein is built up of different amino acids. And so I'll go a little bit into details about what are these and how the different, the importance of the amino acids and how they are linked together in different groups. So if you go to next slide, please. So as mentioned, protein is built up of amino acids. And in typical, we talk about 20 amino acids, which all have a very specific role. So you can't say, oh, I want this amino acid instead of this one. No, they all have different roles, different functions, because they have different structures. So they're all unique amino acids, all of them. What make them to amino is one thing they have all in common is they contain the nitrogen, so N, and the C was from carbon. That have to be a way for all amino acids that have that in common. So when people talk environment or nitrogen, when we also talk about protein and amino acids, because they all contain the nitrogen, is coming from the protein or actually the amino acids. So that's very important when you mention and understand that part of it. And amino acids can be grouped in many different ways because they are something we have in common, different ways. So there's many ways to look at them. And as I mentioned, they all have a very specific role, and I can give a few examples on that on the following slides. Next slide, please. First of all, we talk about amino acids, talk about the essential amino acids, and some of the most important is we always often start talking about lysine, and that's lysine is very important part of building muscle. So that means meat for animals and humans as well. Our muscles is meat, so that is lysine is really crucial amino acids there. That's what we are really seeing is very important there. Yeah, some other examples is methionine for immunity. So if you are staying healthy, the animal's healthy, you need to have a methionine. This is very important amino acids when we talk about immunity to be healthy. If you are fighting off a cold or other infectious diseases, immunity is working, has to work, and it's very important to have a methionine then to can have the immunity system running. And you can see for the other ones, there are some examples as well about how they are really important here. So, and that's just some examples of that. Essential amino acids also called indispensable amino acids, depending which part of the world you're coming from, which we prefer one term or the other one, but they are the same. So just go to the next slide, please. So the other big group is non-essential amino acids. So we have essential and non-essential. So the non-essential amino acids, they can be produced from the essential amino acids. So essential means they actually have to be provided through the dietary intake on a daily basis, whilst the non-essential can be covered. It can either be dietary intake or be covered from the intake of your essential amino acids. So, but if you are eating anything that have protein in it, you're always going to get many of the amino acids. Very rarely any protein will not contain all 20 amino acids. There can be a few examples where they don't, but generally they're always going to contain all of them in different ratios, but depending which the ingredients it is. If you talk wheat, you talk barley, you talk about soybean meal or peanut meal, whatever, they're all going to contain protein, that way amino acids, and all of them typically. So some other examples are somewhere where the functions they have the different amino acids here. So another one for immunity is alanine. That's very important, that part of it. So into immunity. So it's not a one amino acids cover all functions there. So they all play a role in it, but some have more importance in some things than others. Just go to the next slide, please. So we also have a third group we call semi-essential, because that's belonging only two amino acids, that's cysteine and tyrosine. What makes semi-essential is that the cysteine can only be produced from methionine, but not the opposite. Cysteine is very dominant in hair and feathers. That's where we are really finding a lot of that. And like tyrosine can only be produced from phenylalanine, which are essential amino acids. And again, it cannot be but phenylalanine cannot be produced from tyrosine. It's a one-way street. So let's make into a third group of this way of grouping them. Take the next slide, please. So any amino acids you're eating, you don't need for building up muscles or immunity and other essential functions where you as a human or you as animal needs, that will be broken down to produce energy, because that's efficient for the animals. They actually say, okay, no, I don't need to build more muscles. I have all that I need now. Okay, I'll use as energy source. That's make quite a lot of sense, because they have invest energy to eat these amino acids. Say, okay, I need to extract the energy back again when it's possible. I'll do that for the amino acids here as well. And so we have the two, and there's another way we group the amino acids into the glucogenic and ketogenic amino acids. So the glucogenic amino acids broken down to glucose, which is a very important energy source for everybody. And the ketogenic is broken down to ketones. It's another group there, which is also very important for energy source. So and leucine and leucine is only by ketogenic, and some four amino acids, isoleucine, phenylalanine, tyrosine, and tryptophan are both. And the remaining one is all ketogenic amino acids. So this is another way we're grouping the amino acids due to we have different functions. This is about how we're providing energy for the body. Next slide, please. Another way to group them is we call is leucine, the isoleucine, and valine. They're all called the branched-chain amino acids because of the structure they have. Phenylalanine and tyrosine were both aromatic amino acids as the only ones. Methionine and cysteine is characterized as the sulfur amino acids because it's the only two amino acids contain sulfur. And sulfur is an extremely important part of your body because that is what we call building a sulfur to sulfur binding. So it's a bridge we're crossing over. And that is extreme strong binding you have that way. So that's very, very strong, and that's really give a lot of strength into the body. How strong how the muscles are is these sulfur bridges. The muscles, you have said with a muscle from animal, you can't just pull it to pieces easily. It can often be very difficult to pull to pieces. And that is really a lot can be explained because of these sulfur bridges, which are sitting in amino acids between either methionine to cysteine or cysteine to cysteine or methionine to methionine. This is really an important part of that. So they have a really, really strong importance at how we are as humans and animals are, how the structure and the strength of muscles there. So next slide, please. So the main reason to feed amino is really about building muscles to produce meat, but it's also produce enzymes, immunity, and also to excrete amino acids, what we do into milk and eggs. This is a direct excretion of amino acids. We say, oh, there's a lot of protein in milk. Yeah, there's a lot of amino acids in milk. That's why we instead of saying individual amino acids, we say protein, which are represented by the individual amino acids. That's how we excrete the cell. So the function for amino is really to cover the animal's requirement for amino and not energy. So because energy is really covered mainly by carbohydrate and fat. However, aminos will cover energy requirement as well to a large extent if it's needed. So next slide, please. Just to give an example that there is aminos is not, the ratio between them is not constant. So if you just take example here, if you took as a pig here as an example, take the sow milk versus the whole body versus the hair of a pig, how different they are. You can see for a lot of them, the ratio is, the concentration of them is relatively constant. It's not that much a difference. But the one really standing out is the cysteine, that in here you can see that represent a really big proportion versus the rest of the amino acids. Whilst in the sow milk and the whole body, it don't represent that great amount. Just an example about how much variation can be among amino acids for different places you look at it. So next slide, please. Just a little bit about me. This is just to give some example about what I like to have about basic nutrients. So I'm born in 1968 in Denmark. I have a degree in animal science, BS, MS, and PhD. And my role in the FarmingAcademy, I co-head editor, and I'm a content provider. And my main interest is about basic nutrition, also applied science, and I work with, mainly with nutrition across all animal species, and that includes pig, poultry, ruminants, insects, humans, aqua, pets. So basically all everything to do with nutrition. So that's a little bit about me. Thank you.
That was a very good introduction to proteins. And now we are hoping that Pia might go in and take over from here.
Oh, I'm taking over the show. Super.
Yes. Do you want a few slides to help you, or
yeah, that's probably nice. Yeah. I have the worst memory ever.
Oh, that's good being a teacher.
Yeah, I know. I prepared the day before, and when I'm like, oh, 1 second, I need to look at my notes.
Here is a little slide you can use. And you know who made it?
Oh, I've seen it before. Yeah, it's my first course I made, my first lecture. The first lecture I made is just basically what is a pig of kind of an animal. Really short about everything, the circle of life, the pig's behavior, what's the difference on the wild boar and the domesticated pigs, when did we domesticate them, stuff like that. Just really, really basic on how the digestive system works. Me and Carsten probably going to make one really great one later. So that is my first lecture. Sorry. And then I also made one about, I have something in my throat. I also made one about the biosecurity. And I watched actually a webinar yesterday about African swine fever. And it's 1 second. I've been in the pig barn all day and I got something in the throat. And when we talk about African swine fever, PED, all kinds of other diseases, this biosecurity is just so important. So that's the 2 lectures I've made so far. Then I'm going to make one quite soon, I hope, when I have the time. about the reproduction, just how to, just really short basic level, and about the gestation barn, how do they grow, what kind of feed do they need, how do we need to take care of them, what kind of jobs do we have in the gestation barn. And I really, really want to do something about the good weaning, because we need to be out of sync soon. And when we need to be in Denmark anyway, and rest of Europe, how do we take care of them when we wean them? Because it's a really critical time for the piglets. And in the beginning, I'm going to stay a little bit out of the farrowing house, because Karina is really, really good at that. And then I'm going to let her do that first, and then maybe I can make some about that later. Yeah. And then, is there another slide? Oh yeah, this I do remember it by my head back, actually. I'm born in 1992 in Denmark. I'm educated as a farmer in 2004. Then I took a farm manager course in 2007. And then I took this AP degree in agricultural science with pig production as a special in 2010. It's a 2-year. You can build on top of a farmer. Then I'm a content provider and a shareholder at the FarmingAcademy. And I do pig production in general, because my normal day job is being a teacher at this agriculture school in Denmark called Lundbæk. And I teach pig production in all levels and all subjects. So I'm a little all round, but just pig production. Yeah. You want to know anything else?
Hello again. I wanted to know, I heard you talk about alternative sources of protein, and I thought maybe we should call Carsten back to the stage and maybe look at his pretty face. And I think you have some questions for him.
Hi, Carsten.
Hi.
Yeah, it's just because when I teach, I always follow the what's going on. And the other day I mentioned by Jeanette that I thought that insects would be awesome in Africa, but it's because I don't know all these. What does the different new types of protein? What do they do for the pigs? For example, in Denmark right now we're looking at sea stars. We're looking at grass. We're looking at bacteria, and we're looking at insects. And I think it sounds really interesting, because this when we import too much soya, it's not so good for the climate, and we need to take that into consideration. But I actually don't know what all of these does for the pigs' digestive and how they can use them in the body. Can they grow on them? What is good? What is good and bad in all these?
It's actually an area which is really having a lot of attention, and it's a lot of different ways you can, as you mentioned, people are going where, like with sea stars, it's called a blue protein. We have a grass, it says green protein. We have insects, I don't know what you call them. Are you going to call them yellow, or what are you going to call them?
I think they call them brown.
Brown, okay, brown protein, probably. Very well. I actually saw a lot of them yesterday. Insects, they're growing them on a commercial scale. Not for pig feed yet, but it could well be having one day. So it's a completely different world and how we're doing it. The single cell protein we're making now for natural gas, that is actually happened many years ago, and now there's a new facility up and running and going to run commercially and a very big scale. It's a completely different route as well. So you're saying, yeah, alternative soybean meal as a dominant protein source is really helping a lot of things and go a lot of different directions. Common theme is all about environmental benefits of it and the carbon footprinting of these ones. What will be important when you look across all of them, can we utilize them? Yes, we can. All the pigs, I mean, as long as we can digest them. which is most important, is about what are the digestibility of these ones. So I normally say that we look at digestibility, that's one side of a coin. You have to look at the other side of the coin as well. What is undigested? That's the environmental impact afterwards, not before, but afterwards. We have it before, like in soybean meal, have a lot of before because you have to ship it for South America or North America. So there is an environmental cost there. This will have a local grown, so we have a lower that the before cost, but also the afterwards. That's the backside of the coin. So it's really about focus about what are the digestibility of that, how are the environmental impact of it, and how is the balance of the amino acids, because that's really, really important, how to balance all these ones. So one thing is they have a lot of protein in, what does they contain other things as well? What we can say is not as good or can be an issue. So one thing we know about like the sea stars, they contain a lot of calcium. And we know actually calcium, oversupplying calcium have a negative impact on performance. That's been shown in pigs. So we really have to respect that the other nutrients as well. So we cannot just look at, it's convenient to look at the first 4 in nutrients. Now we have to look through the whole list to see what is, do we oversupply for things what is not so good or directly have a negative impact, either on animal performance or directly on the environment. We know a lot of insects will contain tintin, which is an anti-nutritional factor, would make it very difficult to digest for the animals. But that is also about a question about slaking and breeding for that, and maybe also some processing there in the future to overcome this part of it. So it's here we have a lot in. The single cell protein made of natural gas is a bacteria population you're growing that of single cell. So it is it happened a lot of years ago, and there is some old data on it, but it's going to be a new factory is up and running, and they have data so far looking very promising. And it's definitely an area that's very interesting to keep eye on and see what happened there. And grass protein also so far shown it can fully compare with soybean meal. The data so far. The biggest challenge all these have in common is what are cost of production. And that is something they cannot walk around yet. Maybe there could be some legislation doing that. They can be favored. Maybe consumers say no. Okay, we'll say we have diet but zero soy in, we think it's the right thing. When we have when we change the playing field basically with ingredients you use. So a lot of things going to happen in the next 5 to 10 years with protein sources. And that is some of the most important nutrients to provide for any livestock.
Yeah, and it's a very interesting area.
Yeah.
But I was thinking, is it possible that someday when we can make these single cells out of methane on natural gases, is it possible to change it so they can go on biogas and ligger? You know, the small farm when they have biogas, because that would be awesome if you can have your own biogas and then actually make your own protein, you know.
I don't see any reason why it should not be possible. I am convinced it would be possible. You can run your own scale protein, so you make a more circular economy. You own because so you have say you have a pig, you fed that, you have manure go into biogas. You take a biogas, convert that back to protein, so you recycle that way. You cannot run it complete with any new input in because you're selling protein off, like we meat from the pigs. But the losses you're having there is definitely reduce significant. Definitely, you could definitely, and that maybe is the 2030, maybe 2035, farmers be up and running that. I don't think that far away actually. If you really is a focus and there is a research into it, and the law allow it, because that's another thing is that what they explain, because it's all about, as you mentioned earlier, some of your slide, your lecture was about biosecurity. Biosecurity is overruling a lot of things here, and we can never forget that. We should never forget that one, because you see like what happened in China with African swine fever, how it impacted their pig production. They had not anticipated it's going to be that difficult to get out of it. They have been hit really badly again now, because we just see what the pigs are, pig prices, and what are they export of pig meat to China. It means they are still not up and producing again, and and they're some quite a while away from that. So and that's biosecurity is one thing we will never ever forget about when we talk about nutrition or farming or husbandry or anything like that at all.
No, definitely. When they're talking about how to circle around, and we should never ever have things that can compromise the biosecurity. That's for sure.
So,
then we're in really trouble.
Yeah, definitely.
But it was because I was thinking in Africa, there's some absolutely really good soil, but perhaps it would be better, instead of making plant proteins for animals, making food for people, vegetables or something. And then I think the insects would be really great, because you can have them on small space. They can live on something that, for example, there's a Danish factory who makes these fruit bars for kids or adults, if you like them. And some of they can't sell. And then they actually give it to this factory who makes insects, and the insects live on this. And that, I think, is a really great idea. And that could be awesome if you could do something like that in Africa, or perhaps this single cell protein.
If you actually start looking at what are the feed conversion, the protein is up in among the leaders. We are talking about a conversion efficiency, and conversion is as good as aqua. And it's a lot is that's not surprised actually, because it's not it don't need energy to stay warm. The insects,
No.
Like a broiler and a pig and a cow, they need to stay warm. So that always favor these animals that don't need that. That feed conversion generally always can be better. We're really struggling to compete with that for the other species to do that. But it's also a lot about take protein sources, energy sources, which don't have a very high digestibility. We can upgrade them to put them through animals. Like we can't eat grass as a humans. We can't really digest that. You have to give to the cows. Can we do that? Maybe through the insects as an alternative. We can find a way to do that. We can upgrade the things like that. So because the energy source is always going to come from the sun. At the end of the day, that's going to be the main. The sun and the wind is going to be the main one in the future to create the energy for us here, and not the gold and the oil we're taking out. So I definitely see some possibility there to as alternatives there, and we need to understand how we get the best possible way to do it.
Yeah, I do believe that Folum also is saying, give us some more money for research so we can see about this problem, and also about climate in general.
Yeah, definitely.
No, but I have to go really soon. I have like 10 minutes left, because I have a thing at the school too. Jeanette, do you have anything more?
Oh, I always have a lot. I can always go deep, no problem. Just give me a hint. But I wanted to ask Carsten one protein-related question that doesn't really have anything to do with sheep, but
really?
with human beings. Because everybody is talking about, if you want to gain muscle and you want to lose weight, just eat proteins. No fats, lots of proteins. But I think Carsten actually know what is right, and I want him to tell us.
It is the old theory about Atkins diet. You can eat a lot of protein. And the reason why it works to eat a lot of protein if you want to lose, there's a different reason. First of all, a protein have a lower energy concentration than any carbohydrates, including sugars and starch. And fat is by far the one that have the highest energy concentration, about 3 times versus starch. And protein is one of the lowest after fermentable fiber. Or you can eat something that has no energy at all, like cardboard or tree or things like that. It has no energy at all, but it's maybe not so good for your gut health. But else is the lowest one. Another thing is that protein works that way. It prevent you not so hungry. It's a feedback in your physiology that make that if you eat a lot of protein, you don't feel as hungry. It's all about, because the hunger responses is working 2 ways. Partly is a physiology, which is how much insulin you have in the blood, how much energy in the blood, how much insulin are. We work together there. And it's also about how filling up you have. So that's the two mechanisms to make it. Do you feel hungry or don't feel hungry there? So protein, because they're quite generally low, especially some are very slowly by digested. Some amino acids very quickly digested, some is much slower. So it take a longer time before they appear in the bloodstream. It can have to be broken down to create energy. So you have longer time that energy from a protein in your blood versus you eating something very, very processed starch or sugars that they absorb it very quickly. You have this tremendous peak in your insulin, and you make you very happy because you have a lot of energy, but that disappear very quickly. Whilst whereas for protein don't do that. It's much slower process.
But Carsten, is there a difference between, I really don't know that much about human when we eat, but is there a difference between plant proteins and animal protein when we eat them?
Yeah, because they don't have the same amino acid profile. It's very different, or depending which plant it is as well. The meat protein, they have a more similar protein profile. It's going to be less difference there. They're not going to be exactly the same 100%, but while for plant protein is very different. That's very much depending which plant it is. That's a massive difference there. So, and it's also a lot about the ratio among the different amino acids. That's some newer research have actually shown that not been that well researched, also showing a lot about that. We actually can maybe work with different ratios where it could really make a difference about also weight losses in humans, how to manipulate that. There's some data on that, why is that, and that's why some protein supplements really can work very well there. How is because they have a very specific ratio among the amino acids. I can really make a difference there.
I'm looking forward to that solution.
Yeah, no, there is some solution actually there. You can actually do it. You can actually, that commercial products actually, they have that, which we actually can explain from some theory about amino acid ratios. You can buy that, and there are some indication on that. Not as much as we want yet, but I'm sure it's going to come more because there's some more products going to be pushed out in this space here, which come in the future. But as a research area and for commercial, it's really a very appetizing area to be in. Very appetizing because there's really a big demand for it will be, and but it really needs to be rescued better. The difficult things we sit more in that part of spaces right now. What are the digestibility of these different amino acid, different ingredients to make the compromising there? Because in animals, we know very well the digestibility of individual amino acids for different ingredients. That has been researched a lot. When we talk over to humans, and because it's so many more ingredients we're using as a humans, and so many different type of processing as well, that is really making it more difficult, and we don't have that much data so far. We know the reasonable composition of that, but the processing does make a massive difference on it. So that is really we want to look more into. There will come more information about it in the future for sure.
Yeah, awesome. Is it okay, Jeanette, if I go and hopefully meet a lot of new production managers?
Yes, and learners for Farming Academy.
I'll see if there's anyone.
Thank you for taking time to come and tell us a little bit about how much you really know.
And I hope Karina's soon back from traffic.
Yes, me too.
Yep. Have fun. See ya.
See you.
Bye.
Take care. Bye.
And when we talk about Karina, we can talk about Karina without her being here. Let's see here. We can share stream again. Just a second. Because Karina made some very, very good lectures. And they are almost online. In a very, very short amount of time, they'll be online. And one of the very good lectures Karina has done is about the first 96 hours of the newborn piglet's life and how important it is to take care of both the piglets and the sows in that period. But I want to leave that for Karina to explain. But this is just a little reminder that we have that coming very, very, very soon. And now we also have something else coming. Just a second. Because we actually have Karina coming. So we can let her explain. She'll do it much better than I do. So we'll just give her a second. She's just starting up the computer. And she was stuck in traffic, so now you'll also have a little insight into Danish traffic in rush hour. And we're just giving her a few seconds to log on. Then she can present herself. And we can always ask Carsten to talk about something exciting.
One thing I'm thinking about is with the sheep. They always complain about the wolf don't have any money. It's not worth any money at all. So I wonder about this. Right. Why we don't just convert that wolf into protein for some animal species?
Yeah, that could be one way to do it.
I mean, if you could find it right, either single cell bacteria or an insect who will eat that, and we can. Because they are not very appetizing for animals to eat the wool, but maybe you can find some way through that way. Yeah. You want something in the future for some.
It's much better than burning it.
Absolutely. That's not a very good environmental solution.
No. But there's a lot of other things you can do with wool. There is a project in, I think, if I remember correctly, it was in Australia. They actually made wool coffins. They made coffins for dead people out of wool. And that was one way to use it. Yeah. And of course for clothing.
Yeah. But as in it, there's a protein source. Everybody always need for protein. So maybe that would be one to explore there.
Yeah. That you'll have to fix that next weekend.
Yeah, we'll see there. I'm looking for a solution there. You might already find in literature today.
Yeah.
So we'll.
But now we hope maybe we'll see Karina in a moment. I think so. Yeah! Wow! Thank you! We've been waiting for you. And we are so happy you had a chance to join us. And we know it was not your fault. It was all the other traffickers on the road. I'm gonna share my screen. And then I think you have something to talk about, Karina. Because I have a few slides that is something to do with you. If you see here. Now the stage is yours, Karina.
Short about who I am. Maybe. I would say I'm 44 years old, very soon. I have two children, 22 and 17 years old. I have been working for 24 years now. Started in 97 to farm education.
I have to jump in, Karina, and say I don't think your microphone is on. We can hear you, but not that clear. And I know what you're saying is brilliant. Yes. Yes.
Now, shall I try again? Was it so bad sound?
Yes, if you start from the top again, that would be best.
Yes. Yeah. My name is Karina, and I have been working with piglets for 24 years. I took the farm education here in Denmark, started in 97. I have two children, 22 and 17 years old. The last 3 years I have been working as a pig safari advisor. Because my heart is beating for the farming stable. I've been working so many years in the stable that I start to have some problems with my body because it's tough work, but I still love to work in the stable. So that's why I start my own company, and I decide to help other people to have the big results that we all talk about, the low mortality, many pigs on each sow every year, and so on and so on. So this is what I'm doing, and then then I also say yes to this job here. So now I have been making some lectures, and the first is around the first 96 hours from the newborn when they're going to be born and to they're 4 days old. It's here that the mortality often are in the stable. So this is very interesting. That's why I make some lecture about this. Yeah, next page. I have been working 10 years with breeding animals. I start with breeding animals. I start with the race Landras, and it's very, very interesting race. It's a very strong mothership. So I learned on the hard way how to work with the piglets, because pure race animals is not so easy to work with. They are reacting a little bit faster on the negative things. There's not a strong side from two kind of races. When you mixed Yorkshire and Landras, you have two strong sides from the Landras and from the Yorkshire. And when you're working with pure race animals, you only have one strong side for one race. And it's nearly always the strong sides is the winner if there's going to have some problems. So this is also a challenge that you can learn to see that the day before you're going to have problems and then make action. Then you will start to understand how to make a good result when you have learned that. I have also traveled in many countries and give some advices, and I'm still doing that. That's also very interesting with my work. And see all happy people growing when we come and we do everything for the piglets and give some good advices and make some new systems. And yeah, it's just so satisfying to help people. And that's why I think it's very important to do this also with Farming Academy, because then I can give my go card to other people also, so they also can be better to do the job. So this will be interesting in the future, and I hope we soon will be on air with all the lectures that we have made.
And talking about all the lectures, here are some tips for lectures that is very relevant for what we have been talking about today. And first we have Karina's 2 lectures, the first 96 hours and caring for the sow. And Pia, that have just been here, and she had to go, and then you came and relieved her. And she had made some lectures with the biosecurity and reproduction, and like she told before, and Carsten, and I think if we are lucky again, he will reveal his pretty face. Yes, see, he's very obedient. Thank you, Carsten. And you can just present the lectures you have online now and all the lectures you're going to make.
So the ones are right now is just about basic nutrients, protein, fat, minerals. Second one is about how to analyze these basic nutrients. So it's really some introduction courses. I work on some other on about digestibility, some very basic there. And when there'll also be a later work on lecture about something completely not that simple. It's called a Maillard reaction. And the Maillard reaction is something most people in the world have seen or will see sometime in life, because if you toast the bread and it become brown, that's a Maillard reaction. It's a Maillard reaction, give a very nice smell and taste, but it's very important when we talk about feed ingredients and processing as well. Maillard reaction, because they have a negative impact on the feeding value of these nutrients, which really have impact on. Come back to protein, is the lysine, which will be responding to that, and we lose not lysine there. So it'll come some about that. It'll come a lot of presentation also about requirement for different nutrients for different species. A lot about general nutrition and physiology of our different animals. and how they're similar and how they're different. Because some are similar, some is very different with different animals. So it's really about to understand that. So there's a lot more lectures to come over time.
Yes, and I think we have actually taken a lot of questions and answers here. Is there any questions that Karina might have for Carsten?
No.
No, but you always know where to find him. And
Yeah.
everybody needs to know when they have a learner's account on Farming Academy, they can also go in and find the lectures, find the people who are teaching at Farming Academy, and connect with them directly and send any questions they will have. And when you're watching a lecture, if you do a pre-recorded lecture on Farming Academy, you'll be able to, within the lecture, ask questions, and the instructor will get back to you. And you can also form study groups around the lectures, and that will give a lot. And now I'll stop sharing my screen, just reminding you we have a live stream again next week, the same time. And then I think all we have left on the agenda today is to thank everybody who has been here today and say thank you, Karina. And you have been really trying to get here in time, but a lot of people was in the way with their cars, I guess. And they don't know how important Farming Academy is yet, but maybe one day they'll go into the site when they know Karina is going online.
We hope.
Yeah. And thank you, Carsten. And you traveled all the way from England to be here. That was nice. Good swimming. And I'll thank all the viewers we had and say tune in next week and we'll see you again. Thank you for joining us today. Have a nice day. Bye-bye.
Bye.